Hi, hello everybody. I'm George White, and today I'll be giving a 6-minute talk on adding salt to ice. And then I'll go over my reason for it. The outline of it, we're going to start off with some applications of adding salt to ice. We're going to define what salt is. We're going to go over melting point and melting. How salt actually melts ice. Briefly, we're not going to go into too much chemistry in that. Does the temperature of ice or the water change? We're going to talk about some heat transfer, and we're going to close with questions. All right, some applications of salt y'all may know are throwing salt on roads that are iced to help melt the ice into water, and so you got better traction on the roads. Another thing is, a lot of people probably did in elementary school, you put salt in an ice bath, and then you can make ice cream with it a lot faster. Both of those applications are good and useful. All right, salt. It's a compound resulting from a chemical reaction between an acid and a base in which the acid's hydrogen atoms are replaced by the metal atoms of the base. So it's actually really in-depth. It's not just table salt. There are a bunch of different salts. Essentially, they break down into ions when placed in water. NaCl is table salt, and that's what most people think of when they think of salt. CaCl2, though, is the most common used for salting roads, and there's several reasons for it, and we'll go over that in a second. All right, here are two graphs. I think these really illustrate the differences in the salt and what you would use them for. This salt right here, that's sodium chloride, just table salt. And it shows you that it's only good down to a certain temperature. Like, you can't use salt to melt ice on roads down to negative 100 degrees Celsius. But right here, it actually compares table salt versus CaCl2. And this is how much time it takes to actually melt the salt. And that's down to negative 10 degrees Fahrenheit. So you can get CaCl2 can melt the salt much faster than just regular table salt. And that actually has to do with the Cl2. It's got 2 atoms of Cl when it breaks down. It's also got some hydrophobic reactions that actually attract moisture in the water to it. And it allows for it to interrupt the freezing process. And that's really how it happens, is it just interrupts it. It doesn't necessarily stop it, but it helps to interrupt it. And CaCl2 can go down to negative 20 degrees Celsius. It's pretty useful for it. And salt's only like down to negative 10 degrees Celsius. All right. And then the temperature change. So when you actually add salt to the ice, it lowers the melting temperature, right? So in a normal water ice bath, you use in a lot of experiments to get a consistent temperature. You have the ice and then the water, which is melting point normally is 0 degrees Celsius. So that's the lowest temperature that you actually read on here, even though the ice is actually colder. Normally it's not 0 degrees Celsius, it's colder. But you'll only read that because the water transfer, heat transfer is much higher. So it's going to stabilize at that temperature. But when you add the salt, the melting temperature goes down, and then you have water colder than 0 degrees Celsius, and your temperature will drop. And we'll go over the closed system in a second, towards the end of the slide. Again, that's one of the things that I wanted to research when I was doing this, but it was really in depth. And but everybody in here should know what the closed system is. If you have a closed system, you assume it's adiabatic surroundings, then there's no heat transfer in or out, and that'll be important. All right, the heat transfer bonus. So why would you melt ice, like to cool something? Water surrounds its surroundings, so you get a greater surface contact area, and that's number one for heat transfer. And you'll have it at a colder temperature as well. That's pretty much it for that. All right, and we're going to close with this. I'll give you this equation. Ice melting is an endothermic reaction. Thank you, Bryson, for covering that. So everybody should understand what it is. He also said that if there's no heat transfer, it's got to get the temperature will change to account for it. So if you assume the system is closed, and I'm going to put it in a question format because I still didn't get it. If the system is closed, right, so that technically there wouldn't be any heat, I put negative, but there wouldn't be any heat transfer. Your CV, if the temperature is closed, this actually goes down for salt water, but either way, it's got to get the heat from somewhere, and it's got to do it internally, right? So would the temperature actually drop, like colder than just the ice? And I couldn't answer the question. I think it does, because of the bonds that it takes inside the ice to melt. It takes energy to melt the bond, or to break the bonds, basically. And so if you have ice turn into water at a certain, and no heat transfer going into it, it's got to get it from dropping the temperature. And this was inspired by LSU Tailgate last semester in the fall. Me and my cousin got into it. He's a chemistry major. We got into it about, I was like, there's no heat going in or out of the system, so you can't, adding salt doesn't actually make it colder, but I think it does. All right, are there any questions?
All right. Yeah, I got a question. It's potentially a little unfair.
Yeah, go for it.
CaCl2, is that calcium dichlorine or calcium chloride, or how do you, from
Calcium
how do you say
chloride.
that? 'Cause I know
Calcium
there's
chloride.
that's the sulfur.
Calcium chloride. I don't think there is one based on.
I didn't remember my chemistry well enough, so I wanted to ask.
The question was, is CaCl2 called calcium dichloride or calcium chloride? And it's called calcium chloride, from what I understand.
Dichloride.
Chlorine?
Dichloride.
All right, are there any other questions?
It's ionic. It's ionic, so you just
I was
say
gonna
it.
ask who won the
Because
argument.
you know the bond of atoms had to take to form
The
that bond.
question was, who won the argument, and I'm still on the border of it, but I think he won the argument. And I hate being wrong, but I think I was wrong on this one. I think it actually makes it colder. Another thing to consider though, is when you put it on the ice, so what they did was they had a keg and they poured ice on it right in the morning, they dumped salt on the ice, which melts the water and gets the keg colder faster, but not longer. Because your CV actually goes down for salt water, which means the temperature changes faster with less heat. So your temperature actually ends up increasing faster if you add salt, but it gets it down to a colder temperature quicker.
I think you're misunderstanding that there could be heat transfer within a closed system. It would just transport heat within each other.
Yeah. No, I
So it's not, you're not adding heat or taking out heat.
We
It's the
need to
system.
move on though.
But essentially,